Okay, welcome to today's session. We'll be going through practical 2. I'm not necessarily going to write everything. I'm just going to demonstrate on what is really required for this practical. So let me look for diagrams that I can use to demonstrate. Okay, that's not it. Okay, let me go to more shapes. And then, okay, so general software, Android C4. So I'm just adding all these things because I need diagrams, right? I'm not sure which one is going to give me the diagrams that I'm looking for. So let's see. Okay. Wow, there's pretty much a lot of diagrams. Yeah. So this is what I was looking for. Yeah, so these diagrams. Let me see. I don't know if I can find PCs. Let me see. Okay, this would be a tablet. Okay, it actually doesn't really matter. So as long as I have something to demonstrate, right? So let me use this. So let's explain what we're trying to do, right? So we're trying to do what you call trying to generate an email, right? So two devices are trying to communicate via email, right? So two devices are trying to connect via email, right? Okay, this is assembly. So two devices, right? Two devices want to communicate, right? Communicate via, via email, right? So with email, the way it works, right, is that each device, right? Each device has its own mail server, right? Its has its own mail server, right? And then after, so what is a mail server, right? So a mail server is in a way the ability for us to communicate with other devices on the internet, right? Or any device, mail, not mail server, right? It's just a server for the mail, right? So what happens is when you try to communicate or send an email to a person, right, to someone, remember there's a lot of details that are required, but then you need to have that the receive. I'm not sure if I'm spelling it correct. Recipient. The recipients. I don't think I'm spelling it correct. Okay. Yeah, the recipients. Let me just double check. But then, yeah, the recipients. Yeah, recipient. Yeah, I'm not spelling it correct. So, recipients. The recipient's email address, right? And you're gonna need the sender's email address. And you're gonna have the message, etc., and kind regards, all of that, right? But then the main important thing that I want to demonstrate is the recipient's email address, or the recipient and the sender. The recipient is the person receiving the message. The sender is the person sending the message, right? So what happens is each person or each user, they use what we call an application, right, to send the email, right? The application can be Gmail, Outlook, whatever the application is. So this application is called what we call a user agent, right? So what happens with this user agent? Practical to CSC2B notes. So what happens is the user agent, which is your Gmail, your Outlook, any user agent, any device, any application that allows you to read email, it connects to what we call the mail server, which is your mail server, right? So the way I would like to view it is you can view it as like, just think of it as like a garage, right? So you have a garage where where someone, when when a delivery is made, right? Imagine there's a package that's going to be delivered and then they deliver it into your garage, right? So would say that the garage that's receiving or that's able to see what you have received, the garage itself, we can call that a user agent or Outlook or Gmail. That's what it's called, a user agent. It's something that allows us to connect to the mail server. No, no, we'd call no. Let me rephrase that. It's not actually the user agent. It's the mail server itself because that's where you've received the package, right? The package in this case you can view it as email, right, as a message, and it's going to be stored in a garage. And then the user agent is the application that allows us to take the message that we've received from that person, right? Which is from the mail server or the garage. So that garage, that's the mail server. It is the mail or the email. Or you can view it in terms of what is it? What is that called? What is that thing called? Yeah, that's the thing about being Gen Z. We don't know about these terms. You know that thing that you with when they send you when someone sends you a letter, right? The thing that they put it inside in, is it a what is it? Is it a post? What's that thing called? But then yeah, the thing that you know those people on their bikes when they deliver a newspaper or something like that, there's a box that they put it inside of. So that box, whatever that thing it's called, we can call that the mail server. It's like a way of receiving or storing and receiving messages, right? Each and every single person needs to have their own mail server, right? You have your own box to receive the mail, and the other person whom you received the mail from has their own mail server. So this is a perfect demonstration of how it works. So let me do this since I cannot create a new tab since the thing that stores letters that stores mail. What is that thing called? I just want you to see the image. It's a mailbox. Yeah, I think it's a mailbox. Yeah, I think it's called a mailbox. Yeah. Yeah, I'm not used to the mailbox, so I wasn't sure of what it was called. So yeah, this is a mailbox, right? So this mailbox, we can view that as the mail server. That's where your messages are being stored. Just the same way it works in the real world. When you send a letter to someone, it has a message, right? And then that letter gets stored inside this mailbox, right? So this mailbox, we can call that, you can still call it a mailbox, but then it's actually a mail server because the mailbox just a subsection of the mail server. So we can just view this as a way, we can just view it in terms of a mail server, right? So this mail server, this is your own mail server, right? Then your user agent goes to the mail server and accesses the mail or the letter that was received so that you can view it. So the user agent, you can call that, let's say for example, it's your child. you send your son or your daughter to go and fetch the mail, right? That person you've sent to go fetch your own mail from your own mail box or your mail server, that person going to fetch, we call that a user agent. Those are those applications like Outlook, Microsoft Outlook, or Gmail. Those are what we call user agents. They go and fetch mail from your mail server, of which is going to be stored in a mailbox, just like this one, right? It fetches it on the from the mail server. After fetching it from the mail server, it brings it back to you, right? You expect to get the mail back, right? Because you've sent someone on an errand to go and fetch the mail from the mail server, right? So when you send that person on an errand to go and fetch the mail from the mail server, they come back with the letter that was stored inside this mailbox, right? Or this mail server. Then they show you, then you're able to read, oh, this person is greeting me saying, hi, how are you? So let me send a response. And when you send a response, what happens? You still send your child or someone to go fetch it. It can also be you. It doesn't really matter. But then I'm using a different person so that you actually understand what we mean by user agents. So you send someone, your friend or your child to go and put the letter of which you've written your response inside this mailbox, right? Then the people who come and fetch mail, they're gonna come and fetch the mail here, then send it to the post office, then they post it to send it to the person who's supposed to receive it. Then the same procedure occurs. The person receives it also into their mailbox or their mail server. Then they send some user agent to go and fetch it. They can also be the user agent. You can literally go, you yourself can go outside and fetch the mail, right? In that case, you would be your own user agent. So that's pretty much the process, right? So each device has its own mail server, or you can view it as a mailbox. View it as a mail box, right? We have that sorted out. So why do you have to send all these details like your the recipient's email address and your email address and all these things? Why do you have to do all of that? You have to do all of that because it's part of the STMTP protocol requirements, right? So what are protocols? Remember, protocols are they just specify the format the format of the data, and it also tells the computer or tells the computer what action needs to be taken when you see when it sees, right? When it sees certain commands, right? So that's pretty much a protocol, right? Protocol. It just specifies the format of the data and tells the computer what action needs to be taken. That's pretty much it. So when you look at the SMT protocol requirements, right, or the SMTP, what is an SMTP? SMTP just stands for Simple Mail Transfer Protocol. I want you to look at the very important term here, transfer. So this is a protocol so this is the thing that sends your message. So this thing that sends your message, the SMTP or Simple Mail Protocol in full, Simple Mail Transfer Protocol in full, SMTP, is the thing that sends your email, right? It sends your email, and then it also specifies the format your data should take in order for the other person to receive your mail, right? The same way applies with the way you write a letter. You don't just start writing on the way you want. You have to write if you remember in high school in English, this is now English. We're doing English here. If you remember when when you used to get annoyed by your teachers and you're like, why, ma'am? Why say? Why we write? Why do you have to format? Why don't you just write the message to the person? No, it doesn't work like that. There are protocols or there are rules that you need to follow in order for the message to be delivered in the right format, in the right way. The same way you had rules to write a letter, you write your address and the person's address there at the bottom, and then you write Dear Sir or Madam, and then you'd have at the bottom kind regards. Then there was limitation on how many paragraphs you should write. All those things, those are protocols, right? That's just the protocol to write that email, that letter, right? Well, the same protocols that are there, they also apply here when you have to send an email. There's also rules. So we're going to try and understand those rules. So let me go back to this device. So like I said, each device, right? So I think I have too many things now. Yeah, I think I have too many things. Uh, I have too many things. Let me see. So like I said, each device, right? Each device, it has a mail server or a mailbox. So I'm just gonna say this is the mail server, right? So each device has a mail server, right? So I want to demonstrate what actually happens behind the scenes. So let me give it different colors. Okay, that's a perfect color. There we go. So each device is a mail server, right? Which is used to store the mail that you're gonna send or to receive mail from another device, right? It usually serves those two purposes. You can store the mail there. When you're storing it there, that means you're storing it to send it outside, right? The same thing that you do when you want to send your letter, you put it inside this mailbox and then wait for the person with the bike or with the car, it depends, to come and fetch the mail and then send the mail to the post office so that your mail can be sent to the specific person. So the same thing applies with mail servers here. And then what happens is when you want to send a message, right? What happens when you want to send a message? When you want to send a message, you need to format it. You need to follow the rules, the protocol. Which protocol is that? Is the SMTP protocol, the rules for that protocol, which is Simple Mail Transfer Protocol. So those rules are, you need to format it in this way. You need to add this header tag. You need to add this. All of those things, they need to be added, right? In order for the user to receive the message, right? So by header tag, I mean this information like where is this mail coming from? Who is it going to? Who is it going to? Blah blah blah. And then there's a data section. What data are you sending? So you need to write, you also need to write it in this way. You need to say from blah blah blah, this and that. This is quite a lot. And then you need to end with a dot at the end so that it knows that this is the end of your message. And then you need to quit. What does it mean? It means you've quit the connection. So this closes the connection between the two devices, right? So all of those things, they need to be taken into account. So like I said, what happens is you're gonna have that message, right? Which is going to be this big chunk, right? Remember, this link is in your PDF, the practical. You just click on that link. So all of these things need to be followed. You need to structure it in that exact same manner. But then remember, when the ones written in blue, or where there's an S there, which stands this stands for server, it means that's the response that you're getting from the other device, right? So we're going to do that. So we have this. We now know that we need to make use of, okay, I don't need this. I just need this. So each device, right, it has an SMTP interface, right, which is basically um, something that tells that allows it to send mail, right? So let me give this some. Okay, let me give it a different color. Okay, let's make it blue. So each device, right, has an SMTP interface, right? Especially when you want to send email. The SMTP interface is going to allow us to be able to send message from this device to that device, right? That's what this SMTP is for, and that's why it's called Simple Mail Transfer Protocol. But then the mail, it needs to be in the right format before it can be transported or sent. You see, all of these rules need to be followed. So your user agent, it's doing all of these things behind the scenes. You don't even know it. You'd be like, oh, because things are just so convenient nowadays. You just read emails just like that. If though you didn't have user agents, you'd have to write this every time to read the message, which is very complicated. So that's why we have user agents. They make the job easier. So the question is, look at these devices. They're in different locations. How will they connect with each other? The way they connect with each other is through what we call come on, where's the okay, it's not allowing me to add a line. Let me see. Okay, it's not allowing me to add a line, so it's fine. I'm just going to stretch it out like this. So what happens is, in order for this connection to take place, right, there needs to be what we call a TCP connection. In order for you to send email, there needs to be what we call a TCP connection, right? Remember, TCP is transfer control protocol. So that's what's going to be needed here. A um, TCP connection. So there needs to be a TCP connection, right? So that we can be able to send this, come on, so that we can be able to send the messages, all these emails to each other, right? We need that connection. We need to connect, right? So how do we establish this connection? The same way before you, let's stop thinking about it in terms of letters. Let's view it in terms of when you're typing, right? If you want to tell someone something, right? What's the human protocol? What's the normal way as humans to initiate the conversation? You start by saying hello. You start by greeting, right? You start by saying hello. If you get back a hello, which is from the server, the other device, if the other device says hello, then you have initiated the conversation. You have created um, a connection. In this case, it will be a human connection, right? In our case, we're going to have a TCP connection, which is a transfer control protocol connection that allows us to now that allows our servers to now communicate. Because remember, the server is like the mailbox. That's where we're going to be receiving and storing the messages. That's where we're going to be receiving messages from other devices or other mail servers. And that's where we're going to store our own messages to send to other mail servers. So there needs to be that TCP connection. Once the TCP connection has been established, and it's established through starting saying hello. If you get back a response, then you know, oh, okay, it means that everything went well. So we have that. Okay, let me go back here. So this is pretty much what's going on behind the scenes. You have SMTP, which is going to send your mail to the other device. And then in order before you can send, there needs to be what we call a TCP connection. And then the other device can receive the they can receive the mail, right? You can receive the mail. So you might ask yourself, how does it receive? Because I said SMTP is meant for sending. How is it receiving? So the way it receives is there's a lot of steps, right? You can receive through POP3, and then you can also receive through IMAP. That's how you can, these are the protocols that you can use to receive the actual email. Each protocol has its own benefits and things like that. We don't want to get into that in this practical because we are not actually writing a server, right? We are not actually implementing two devices at once. We're implementing only one end of the connection. We are only implementing one end of this connection. We don't care about the other connection. If we're implementing both, then that's a different case. It's a totally different case. So we have this device, we have a TCP connection, there's my mail server. It's going to connect to another mail server, then we exchange emails, right? Or electronic mail, right? Remember, that's what email stands for. It's electronic mail. That's why I said they extracted it from the real world concept of sending mail through mailboxes. That's how they constructed it. So since we have a bit of that understanding, we now know that the SMTP protocol has rules behind this thing. There's certain rules that need to be met before you can, in order to establish the connection, in order to send, how should you send the data? Or you need to write the person's email address, their the postal code and things like that, so that we know who to send it to and things like that. There's all these rules that need to be followed in order to exchange mail. So we have this simple demonstration. I think this should suffice. And then remember to receive mail, right? The other device, in order to receive mail, it receives it through, I'm just gonna only talk about IMAP in this case, but then there's also POP3. So it usually has this uh, two or three, it depends. If you're receiving it on the web, via web browser, right? It actually uses what I call an HTTP protocol, which is a hypertext transfer protocol. So you're transferring hypertext, which is like web-based text. So it depends. That's why I'm saying we're not getting into that because that's not the purpose of this practical. The practical is only, you're only worried about sending, not you're basically only implementing one device, not the other, not both devices. So I'm only focused on this client, right? Or the sender, not the recipient. I don't care about the recipient. So I'm just gonna leave it like this, and then we have a bit of understanding of how everything works. So let's try to initiate a send email, right? So I'm gonna call this SMTP underscore tutorial, right? We're just getting an introduction to SMTP, which is Simple Mail Transfer Protocol. And then I'm gonna add a class called main. It's going to have a main function. So in this case, in my case, right, I'm not going to make things complicated and add GUI and all that. I'm just going to show you how everything should be initiated. I'm not going to add GUI, which is the graphical user interface buttons, and that's going to take a lot of time. The video might end up being 3 or 4 hours. So let's not get worried about that. Let's just see how to initialize this thing. Remember, in order, each device is right. Each and every single device it has what we call a socket interface, which allows us to connect to other devices, right? So this socket has a specific set of rules that need to be followed in order to connect to other devices. So we're going to connect through, we're gonna use that socket interface to connect. So I'm gonna start by making it null, right? And then I'm obviously gonna need a try catch, but then let me add that after let me just add it automatically. So I'm going to say socket, which is my object, right? So I'm going to say socket is equals to new socket, right? We are creating a connection here, right? I'm trying to connect there. So it takes in two things. It needs the address, which is the IP address of what I'm trying to connect to, and the port number that I'm connecting to. So I'm gonna connect to localhost, right? Which is myself. Yourself meaning your actual physical computer. So that's because it's simpler that way. We don't want to connect to other devices because now I'll need two laptops in order to connect to another laptop, right? Which becomes cumbersome. So we're not gonna get into that. So what port number should we use? If you check the port number for email, right? For sending mail, the default one is 25. That's the port that specializes in sending emails. And then if you want to make it, okay, so if you use port 25, it's not really as secure. There's no security built in, right? There's other port numbers that you can use if you want a secure connection, right? But then those ones you need to have your SSL connection, all those complicated things. We don't want to complicate our lives, right? So we're trying to make it as simple as possible. So what this will do, right? It'll connect to my mail server, right? It will allow me to create a connection to my mail server because that's the mail server. It runs on that port, right? Port 25, so that I can store the messages that I want to send to another person there, or I can use it to send to another device, right? We always use our own mail server to send to another device, and we also use our own mail server to receive messages from other devices too. So if this goes well, remember if it's gonna remember with the assignment operator, right? This equal sign. We start with what's on the right hand side. If the right hand side fails, then an exception is going to be thrown. So when can it fail? It can fail under two conditions, right? The host is not known. The person you're trying to connect to the other end system, right? Or the other host, it does not exist. So you can have that case. So I also need to catch that. So catch unknown host exception, right? EX. So the host might be unknown, the host that I'm trying to connect to. So I need to make sure that I'm connecting to the right host. So what I'm going to do is I'm going to output sys error. Nope. Sys error to output an error, and then I will say unknown host, right? It needs to be a friendly message. And then here, the IO exception, right? The IO exception can only occur if you couldn't connect to that port. That's when the IO exception will be triggered, when you could not connect. So I should output could not connect. There's no need for me to write the port number. And then finally, I need to have a finally block that whatever happens, irregardless of whatever happens, this will be executed. This will definitely be executed, which is the finally block. So I need to close my connection, right? So remember here, I'm trying to create a connection to to my mail server so that it can connect to the mail server of localhost of that other device, right? If you let me see if it's still going to show. Okay, it's not going to show, so let me open it. So if you remember, come on, why is it doing this? Okay, but then if you remember, we have each device has its own mail server, and there's that line there, that TCP/IP connection that allows the two devices to connect, right? We'll try to establish that in this one line. There's a lot we're trying to do, but then in simple terms, I'll just say here we're trying to establish a TCP connection. That's pretty much what you're trying to establish. You're trying to connect to the other device. So that means connecting our mail servers to each other so that whenever I send or our mailboxes in whatever way you want to view that. So that if I have a message, I will send it, I'll put it inside my own mailbox or my mail server and send it to the other person's mailbox or mail server. So before you can do that, there needs to be a connection that's established. So I'm going to check if my socket was not null first before I close it, because I also need to close the connection once I'm done connecting, right? So socket dot close. And then it's going to need you to surround it to try catch because there might be an error when you're trying to close the socket, right? But then I don't know why it's doing that because we actually check if it's not null before we can proceed. Yeah, that's Java for you. There's a lot of default error handling. These are these are checked exceptions. You need to make sure that these are checked before the program, or else the program won't run. So if you remember last semester, checked exceptions. That's what's going on here. So if everything goes well, right? In this line, you see this line here, where I've highlighted, then it means that we were able to connect. So I could output and say connected, right? Because we assume that if it didn't go and catch these exceptions here, then it was able to connect. So that means it was able to initialize this socket object. So let's run it and see. There we go. It was able to connect. Let's try changing the number so that you can see let's make it 26. Let's say we didn't know the port number to connect or the port number that works with emails, right? Let's say 26. You see, it outputs an error, could not connect. That means it couldn't even get to that line under the socket is equals to new socket. Because like I said, it's going to start by trying to do this. If this fails, that means this won't be initialized. That means it's going to throw an exception here, an IO exception, input output exception, which is we need to phrase it in the right way and say it could not connect. So yeah, we have that understanding. So let me see, 38 minutes. Okay, so now there's another way that I can get the response from the other device, right? Remember the other device is called localhost. That's the device we're connecting to. So let's try to get a response from that device. How do we get that device? So now comes the important things there's two things that are important here. Print writer and buffered reader, right? Remember these are subclasses of the writer and reader classes, right? Classes or interfaces. So these two are subclasses of these two superclasses, writer and reader class or interface. So writer, it's in the name itself, is to write. So we are writing it or sending that thing to the other device. And then you're reading the information that was received from the other device. So how do we initialize it? How do we go about setting these things, right? So to set this thing, right, we need to actually understand what are streams. So streams, basically, think of a stream, right? You can think of a stream in general. So let me try to, so let me see if I can see images, right? So you see there's a stream, right? A stream of what? So you see it's like a path, right? It's like a line, it's like a path, right? Or a road. But then you can view that as like a path, right? So it streams, that that path or that tunnel or however you want to view it, it allows us to read data, right? But then data meaning we can read bytes, we can read primitive data types, we can also read objects, right? We can read all of these things through streams, right? So there's two different types of streams. We have what we call an input stream, and we have what we call an output stream. An output stream meaning that you want to output, you want to send. It's like a tunnel whereby you send information to the other device. So at the end of that tunnel, there's the other device that's receiving. So that device that receives what you've sent, it uses an input stream, because to that other device, it views that thing that it has received as input. I hope you understand these two terms properly. Output stream, you are sending it onto the output stream, onto the, like I said, stream. Think about stream as like a path or water or a tunnel. So output stream, right? Output stream, this would allows us to send data, and data can be bytes, primitive data types, or objects. So yeah, so remember I said read, you can also read and write. It's all it's all read. Let me phrase my notes properly. Read allows us to read or write data, bytes, and data can be bytes, primitive data types, or objects. So an output stream allows us to send the data, and we send it onto to send data onto the stream or the output stream to another device. We send the data onto the output stream to another device, and then input stream allows us to receive data from another device's output stream. So you can imagine there are two roads, right? You can imagine there are two roads. Let me demonstrate this using Dia. So Vertex Academy slide the nodes and then SMTP, right? Let me see. Choose app on your PC. Okay, let me do this. It doesn't want to open. Let me choose. I think it's the one I saved as SMTP, right? Yeah. So let me open an existing diagram. Let's try again and see. Okay. I don't know what I selected last time. So there's our demonstration, our diagram, right? So like I said, you can imagine that each device has both. Just make sure you understand that each device has both. It is like a tunnel, right? So it is this sort of like these pipes, right? Where a stream of data, just like a stream of water, we also have a stream of bytes, a stream of primitive data type, a stream of objects. can be sent from one device to another through streams, whether it's an input stream or an output stream. So in this case, right, we have both on both devices. Just you need to understand that we have both on both devices, right? So so what I'm going to do, right? I hope this makes sense. So imagine this is the stream that's connected to that, right? And then this is the stream that's also connected to that. They're connected to each other, right? And then we have this, and then we have this. Just imagine these are streams, right? There's nothing special about streams, and there's nothing, I don't see anything too hard about understanding these topics, right? If you actually watch all the videos, you'd understand. So the way you can view it, right, in simple terms, let's think of this as like the output stream, right? Output stream, which is like the path that you're going to send the output through, right? It's like the pipe where the output travels through, right? Let's view it in that way. So let me see. Too bright. Yeah, green should be fine. So you can imagine the ones that are green is output stream, right? The ones that are green. No, okay, this would be okay. Now okay, this is not going is the way I expected. So let me do this. So green. So this would be the output streams, right? Output meaning it's pointing to the other device to show that it's going to be sent to the other device, right? And then input stream, you can just view it as like receiving, right? It enters into this pipe. So input stream, right? And then we have this, and then let me give it a color. Let me just be wild and make it orange. Okay, so there we go. So we have these streams, right? So output here, what happens is when you send it, when you put it onto the output stream, output meaning that it's ready for output or to be sent to the stream that outputs to the other device or that sends to the other device. So obviously, the other device will receive it through its input stream because that serves as input to my device because I'm receiving its input to me since I'm receiving. And then the other device, if it sends back a response to your device, you will receive the message through input stream, right? But then the other device will send its data via the output stream because it's outputting to your device or it's sending to your device. So that's how it's going to work, right? So this is going to send the data, right? The data is sent to this input stream. Then this one is going to check its input stream and read what's on the input stream. So since we have a bit of understanding of the clear picture, right, of what's going on, you send the data there and then the input stream receives the data, then you read what's on the input stream, right? So since we have the understanding of an output stream and an input stream, we need to understand another thing. So input stream and let's just say input stream. For now, let's talk about input stream, right? input stream or the stream, it works with bytes. Stream works with bytes by default, right? So in order for us to sort of like work with primitive data types, remember we want to be able to work with primitive data types and objects, all these different types, right? So we need to be able to interpret the bytes in such a way that they're interpreted as a specific data type or an object. To interpret those, we need to use what we call an input stream reader, right? This just allows us to interpret the bytes in terms of primitive data types, right? We don't want to be interpreting them in terms of bytes, like 8-bit digits, right? Like in terms of zeros and ones. We don't want to be interpreting them like that. But then since we have a way of interpreting them as primitive types or as data types, we need a way to store, right, in sort of like a queue, all the data that's incoming, right? All the data that's incoming. Remember what we talked about in the video with introduction to computer networking, right? When you send data, it gets split up into small pieces or chunks that are called packets. So when you send information to another device, the information or data is split up into pieces, right? Which are called packets, right? So don't forget that this data is going to be um, divided into packets, and then it's going to be sent through this tunnel, this output stream, right? And then this output stream, remember that they take independent paths, right? Or independent routes or roads, whatever you want to phrase it, but then we phrase that as a path. Each packet may take its own path to get there. What do I mean by that? So you see, this is one way to get there, right? You go straight and then you turn right and then you turn left and then you get there. The other way is I can just go like this. You see, there's another way to get there. I can go straight and then just only turn right and then I've arrived to the location, right? So that means those packets or those pieces, right, they're going to arrive different in different locations and also at different times. So we need a way to queue or store them as they arrive, right? As they arrive. We do that through what we call buffer, excuse me, buffering, right? Buffering, it means that you're going to keep storing them in terms of queues. Like imagine you're the first person, you're in a queue to buy ice cream, right? Or a Pick and Pay. You're in a queue. The person is gonna, obvious you are in front, the person found you in front, right? They can't go in front of you. They have to go behind you, right? So another person comes and then they go behind that person who's behind you and so on and so on. So all that, when it's now stored inside a queue or it's now in a queue, all those different pieces or those different people in the queue, we can call them those packets. We can call them packets. Those people in the queue, we can call them packets. They are now stored in a location called a buffer, in a buffer. And then that one buffer, when it's full, we can read the whole chunk of information. It's like if it was possible, right? Imagine all those people in the queue, one by one, all those packets. You 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 think you you handle their request, right? You all of them all at once, they pay for their grocery and then they leave all of them at once if it was possible. So that's what buffering does. It allows packets to be stored in a queue in the and in it's going to be stored in the order that it was made, right? If you remember the first video, that's why I always say watch the videos that I upload. Because if you don't watch, you'll be clueless. I am explaining it as simple as possible, but then you still be clueless. then there's people in your class who are just going to get it just like that, and then they get 100 in everything, and then you start feeling insecure about your intelligence. Whereas it's not really about that. It's really about effort, putting in the work. So better watch everything. I know some of you, majority, are not gonna watch this. I guess we'll see you next year. That's all I can say. So buffering, we've buffered. So how do we buffer that? We buffer it through we're going to buffer it through what is it called? A buffered reader, because we need to read the information, right? So we're going to use what I call a buffered reader, right? We will use a buffered reader to store those packets in a queue, and then we read all of them at once. Because buffering, if you remember, last semester I made a video that was talking about buffering extensively. I cannot keep repeating myself on that. That's something you need to go and fix. You need to go and watch the video. So we have an understanding of everything. The output stream, you put it on the output stream when you want to send data to the other device. And then the other device's input stream, which is the opposite of that, right? If you notice, it's always opposites. Output on the other side, it means the input stream. Because the other devices, it treats that as input or incoming data, right? So obviously it's going to use the input stream, that channel for input, since it's going to be receiving this data. As you can see, it's in the name, input, output. So I did try my best to explain that. I hope majority of people understand. So we don't need to check if it's connected, right? If you check on your PDF, right, your practical, it shows you a link, right? Let me show you. There's a link that you need to click here. It tells you refer to that for information on how this is done. You need to refer to that. You can't expect to answer this practical without referring to that. Learn to follow instructions. So I refer to this, there's the link, right? So what happens is this is the server. So let me see. When you have two devices, right? Those two phones that I had, the one that's sending the data is typically called a client. The one who's receiving the data is typically called a server. Both one device can play both roles. Because remember, the server needs to send me back a response. Therefore, the server is going to act as a client. Then I will act as a server, the person receiving, right? Both devices can do both. But then in simple terms, a client is basically the device sending the information, or the device sending the packets. Let me use proper networking terminology. And then server is it's not the device, it's called the host or end system. By device, by host or end system, we just mean a computer or a phone. The tool that you're using to send, that's a host. That's an end system. It's called an end system. If you check your slides, because it typically sits at the end of the computer network itself. That's why it's called an end system. And then the host or end system receiving the packets. That's all you need to know about client and server. So obviously, you see, like I said, the one in blue is the response from the server. And if you remember our diagram, remember what I said, both devices have input stream and output stream, so that you can either send output to the other device via the output tunnel or via the output stream, or receive data from the other device via the input stream or the input tunnel, right? So let's initialize these input streams. So to initialize these input streams, we need to pass them, we need to use two things, right? Print writer. And remember what I said, it's usually in bytes. So the way to interpret it in terms of primitive data types, we need to use a print writer and an input stream reader. Those are the two things we need to use. But then remember, packets they arrive in at different intervals, right? And at different they arrive independently, so they need to be buffered. So I can't just use an input stream reader only. I have to actually use a buffered reader. Okay, let me call this one out and then this one in, right? In standing for input. That's the input I receive from the other device. So there we go. So let's initialize, right? Let's instantiate or initialize our streams, right? So that we can be able to send out communication and receive back a response. So let's do that. Let's start with print write. So the print writer, what's the name? The name of the object, it's out. So the name is out. So I'm going to say is equals to new print writer like this. And then what is supposed to take in? Look at this. You see, that's what I like about code. What is this? Now I'm saying code blocks, thinking about C++. That's what I like about Eclipse. It has a lot of documentation. Look, output stream. You see, it expects an output stream. So I can't just say output stream like that. Because if I just say output stream, I'm saying an output stream from where? Where is it? Where's the connection? Where am I getting this output stream from? So I need to get it from this socket, this object that I use to instantiate or create a TCP connection. So that socket where I am connected with the other device, I need to use that socket and get the output stream, right? And get what's on. I'm going to get what's on that output stream. So far, can you really say that we've received anything? We haven't, because remember, I'm implementing a client. If you're asked to implement both the server and the client, then it's a different case. Here, we only asked to implement the client, so I'm not receiving anything so far. Okay, I'm not outputting anything. My bad. I'm not outputting anything. I'm not sending anything to the output stream, right? And then I'm gonna say comma and then put true. True, it means auto flush. So when you go to the toilet and you flush, it's exactly that. It's the same concept. So when I put true, it means that it's going to automatically flush. Automatically flush, it means after using the toilet, imagine you could just stand up from the toilet and then it flushes on its own. That's what this true stands for. It means just automatically flush once you're done using that stream, right? And then and if you don't flush, it's going to be a problem the next time you want to use it. I hope the example makes sense. And then I'm going to say in to initialize my buffered reader, right? So new buffered reader. So this buffered reader, right? If we check, it takes in a reader, right? And remember, we talked about input stream reader because we want to be able to interpret the bytes in terms of primitive data types. So I'm going to pass in new input stream reader. And then after passing input stream reader, right? Remember, input stream reader is just the reader for reading my input stream. So I'm going to read my input stream in terms of primitive types, not in terms of bytes. So obviously that input stream itself, it has a parameter, which is an input stream. What input stream am I referring to? The one from this socket that I've used to establish a TCP connection. So I need to pass it as a parameter here and say socket.get already shows me the very first thing that I'm looking for, get input stream. So now I can work with this input stream from that socket. So remember the input stream reader or the buffered reader, it's meant to read. So like I said, if everything goes well in this, only in this one line, then we know we have successfully connected. If we look at the website that they gave us, the Wikipedia website, the server, as you can see, this is a server. The server automatically gives you a response before you even try to initiate it. Before you even try to initiate a TCP connection, right? The connection itself, right? Okay, let me not. I think I mixed something that I shouldn't have mixed. This is not actually a TCP connection. We haven't actually done the TCP connection yet. This one just allows us to connect to this device on that port number to be able to send emails, and we need a socket for that. Remember, each device has a socket interface to allow us to connect to other devices. So the TCP connection, we not necessarily done it yet here. We'll do it. You see, when do we do it? When we say hello and we get a response. You see these two lines here. This is what initiates the connection. If we get back a response, obviously, you know, okay, that means I can continue and say what I want to say. For example, imagine for the guys out there, imagine you're walking in the street and then you see a beautiful lady and then you want to court the lady, right? Or so, or or in a language that you can understand, you want to share the girl, right? You approach the girl and you say, hello. If you don't get a response back, that's a clear indication that she doesn't want to be bothered. That means you couldn't initiate a connection. There's no bond. There's no connection. Don't try to force it. So that's exactly what's going on here. If you greet her and then she says, oh, hello, and then let's say you greet her and she says, oh, hello, how are you? With a smile on her face. That's a simple indication that, okay, you can initiate conversation, right? Like you can create the TCP connection or the connection, even though the person might just be saying, hey, there's not really romantic feelings for you. But then I'm just saying, at least it's like it gives you that sort of like hint or clue that, okay, this person is giving me the platform to do what I want to do. So that's why I'm saying these two lines allow us to create what I call a TCP connection. That simply says, okay, you are allowed to, you've connected to that server. You're allowed to send messages to me and I will respond back to you. So before we do that, right, as you can see here in this first line, I mean, we already get a response before trying to create a TCP connection. We already have a response. So that means I can use my buffered reader to read. So I'm going to say system.r, right? Because I want it in red so that we can see. So I'm going to use my input stream, my buffered reader, which is in, and say in dot read line, right? So I read the whole line from the buffer. Basically I read the response that I got from the server, right? Which is, I'm expecting something similar to this. You should end in postfix and you should have ESMTP, right? So let's test it out. And then boom, we have it running. ESMTP read. You see, it tells you it's ready. You see, it's telling you that I'm ready, and then it's showing you the version number. And then the service that I'm using, it's Papercut, right? Here they just said it's some example, something, right? There's the 220. 220 in this case would mean that everything went well. So it's the server is telling you, okay, you've successfully connected to me. I'm ready to talk to you, right? To have a conversation. Okay, it's like I'm ready, right? So you're gonna after connecting to that port number, we're gonna try to establish the connection, right? We're going to greet, and if we get a response like hello, we get back that response, then we know everything is good to go. So I think I should stop the video here. and then I'll continue in the next recording. That means we'll have part 2. So see you in part 2.